three parts to this process of getting energy out of your food, which is what cellular respiration is all about. There is glycolysis, or as the name implies, the breaking down of glucose molecules. Okay. There's the Krebs cycle, named after Dr. Krebs, later renamed the citric acid cycle because it's just easier to remember than Krebs, because Krebs doesn't mean anything, it's just someone's name. And then the electron transport chain, which is the final step in cellular respiration. So some organisms only are going to undergo glycolysis. That's all. They're not going to ever get beyond that because they don't either they don't have the machinery or they don't have some required component like oxygen, perhaps. You undergo glycolysis as well. All organisms do. So glycolysis for most or for many is when only quick bursts of energy are required, and then you go back to undergoing cellular respiration. So, like I said, some organisms are only going to get as far as glycolysis. I'm going to go back a slide. Remember, there are three stages: glycolysis, the citric acid cycle, and then the ETC, or the electron transport chain. Some organisms never get past glycolysis. So, like I said, glycolysis, you're going to do it. Some organisms are going to do it when they need quick burst of energy. But it's also necessary to set up the second two stages, the Krebs cycle and the electron transport chain, which you'll see in a second why we're doing those, that you get much more energy out of them. So glycolysis takes place in the cell's cytosol. Okay, you should remember that's just sort of the liquid inside of the cell. Whereas the Krebs cycle, or the citric acid cycle, and the electron transport chain actually are going to happen inside of the mitochondria. Okay. The Krebs cycle and the electron transport chain are going to happen within the mitochondria. And this here might give you a clue as to why some organisms never get past glycolysis. So if you were, say, for instance, a prokaryote, if you remember what a prokaryote is, it should be pretty obvious why you can't undergo the Krebs cycle or the electron transport chain. And it's because you don't have a mitochondria. You don't have any organelles. So all you can do if you're a bacteria or a protist is pretty much glycolysis. Okay? Once you get beyond that, it becomes impossible to do anything else because, again, you have no membrane-bound organelles. So glycolysis only gives you 2 molecules of ATP per molecule of glucose. Krebs cycle gives you the same. So if you can only get through glycolysis in the Krebs cycle, you're only getting 4 molecules of glucose. But what they do is they give us, what they do is they give us a whole bunch of electrons that are carried to the electron transport chain. Okay, and I'll go back a second. So glycolysis and Krebs cycle, they don't give you very much energy, but what they do give you is a whole bunch of electrons which are carried to the electron transport chain, which give you a whole bunch of energy. Electron transport chain gives you about 32 molecules of ATP per molecule of glucose, okay, which is a lot more. So here is it's showing it to you as kind of like a little coin machine thing, and it's giving you, you're putting in glucose. Okay, so if you were only to go through glycolysis, you only get 2 energy tokens or ATP molecules. Okay, so most organisms are sort of, not most, but a lot of organisms are cut off here. They don't have mitochondria, so every molecule of glucose that they put in, they can only get 2 molecules of ATP out. They can only get 2 molecules of ATP out. But if you can take those molecules of ATP and you can strip away some of these electrons via your NAD, okay, that's the electron carrier we talked about in the last lecture. They can go into the Krebs cycle, which gives you 2 more energy tokens, 2 more molecules of ATP and some CO2 out. But this Krebs cycle generates more electrons. More electrons come out of it in the form of NADH and FADH2. We didn't talk about FADH or FAD+, but those are just more electron carriers. Those are going to take it to the electron transport chain, which gives us the big payoff, 32 ATP, 32 energy tokens. All right, so the process of putting in one glucose molecule, stripping off some electrons, stripping off some more electrons, and then running those through this thing called the electron transport chain gets us a bunch of energy, gives us about 36 total ATP molecules for every glucose molecule that you put in. So we're going to go into some of the details of glycolysis, or actually breaking down that sugar, in the next lecture.